Today we're going to talk about similar solids and how similar solids work are very similar to similar triangles and similar polygons. So the first question we have to ask ourselves is, how do I tell if two shapes are similar? Well, I have two criteria to determine whether or not two shapes are similar. First criteria is all angles must be congruent. And when I talk about all angles, I mean all corresponding angles. So not all the angles have to be the exact same, but all the corresponding angles have to be congruent. And then the other piece is that all corresponding sides share a common ratio. When we talk about common ratio, that just means the same thing as a scale factor. So if there's a common scale factor, it's a common ratio. That common ratio is my scale factor or my similarity ratio. So if we look at these examples below, it says determine which pair of solids are similar. So to determine which ones are similar, I have to test all of the corresponding sides. So 6 corresponds to 8, so it doesn't tell you which direction to go, so I just always do little over big, 6 over 8. And then 13.5 corresponds to 18, so 13.5 over 18. And then 4.5 corresponds to 6, so 4.5 over 6. So now I'm going to go ahead and I'm going to simplify all of these. So I can go ahead and simplify these in my head, or I could type them into my calculator. So I could type in 6 divided by 8, and then I could hit math, enter, enter, and I would get 3/4. And then I could do the same thing with 13.5 over 8. Type that in my calculator, hit math, enter, enter. I get 3/4. And last but not least, if I type 4.5 divided by 6 and get that and hit math, enter, enter, I get 3/4. So because all of my ratios are the same, I can say yes, these rectangular prisms are similar. So go ahead and let's do the next one. So 7 is my radius of my big cylinder, 4 is my radius of my little cylinder. So 4 over 7 equals, and then I have 10 corresponds to 16, 10 over 16. So if I go ahead and simplify these, I get 4 over 7 equals 10 over 16, math, enter, enter, is 5 over 8. Notice those ratios do not match, which means these cylinders are not similar. So because these rectangular prisms were similar, and if it asked for that common ratio or my scale factor, it'd be 3/4. Here, because these cylinders are not similar, I have no common ratio or scale factor. So now if I'm looking at these problems, it says assume they're similar. So I'm telling you that they're similar. Find the missing dimension. So when you have similar shapes and you're looking for a missing dimension, what do? Well, you set up a proportion. So it does not tell you whether you start with big or little. So I just, whatever you want to do. 4 corresponds to 10. So I'll do 4 over 10 equals 10 is the diameter of the big one, D is the diameter of the little one. So big over little and then big over little. So now I'm going to go ahead and cross multiply. I get 100 equals 4D. So D equals 25. So sure enough, this looked like it was a smaller one, but it really actually wasn't because it's bigger than the big one. But that doesn't matter because we just assume things aren't drawn to scale. So if you look at this next one, I want you to go ahead and pause this video and try this problem on your own. Notice you have a bunch of unknowns. You got to find the letter B, you got to find the letter H, and you got to find the letter C. So you're going to have to set up a total of 3 different proportions to solve. When you finish, unpause the video and my work will be on the screen. So my answers with my work are available for you to review. Make sure you ask me questions if you have any. So if we keep moving along, it says, remember, when we are comparing two similar shapes, area, volume, always think what? What should you always think? SPOV. SPOV is always going to help us out when we're trying to talk about something similar shapes. I write this on my paper always just in case. Worst case scenario, I don't need it, but a lot of chances I will. So another thing we really have to remember is how do we write scale factors? So how do I know how to write scale factors? Does anybody remember? Well, it's scaled over original. So it's my scaled image over the original image, where your starting is on the bottom, where your going is on the top. So it says solid A is similar to solid B, which is not shown. Given a scale factor of A to B, find the surface area and volume of solid B. So since it says my scale factor is 1 to 2 and I'm starting with solid A, 1 relates to A, 2 relates to B. So I'm going to go ahead and I'm going to instantly write SPOV on my paper. And I'm going to go ahead and fill this out. So it says my scale factor is 1 over 2. So P is 1 over 2. What's A? 1 over 4. What's V? 1 over 8. So it says find the surface area and volume. So S stands for surface area, V stands for volume. So let's do surface area first. So if I'm looking for surface area, what ratio do I start with? I start with A. So 1 over 4. And then since this is all of A and A relates to 1, 150 pi goes on the top, X goes on the bottom. So I have 1 times X is X, and 4 times 150 is 600 pi inches squared. So that's the surface area of the bigger cylinder. So now if I want to go and I want to find volume, so now I'm looking for volume. What ratio do I start with? I start with the volume ratio. So 1 over 8 equals 250 pi, except I wrote 200, let's change that. 250 pi over, I'll say y since I already used x. Cross multiply, y equals 2000 pi. Since y is my volume, units done, inches cubed. I'm finished. I knew A went with 1 and B went with 2 because I started with A, I went to B. So it's just easy that way if it doesn't tell you which one's larger and which one's bigger. So if I go over and I look at number 2, it says my scale factor is 3 to 1. So since I'm going from A to B, I know 3 relates to A, B relates to shape B. So I'm going to instantly write SPOV on my paper because I'm talking about two similar images. And 3 over 1 is S, 3 over 1 is P. What's A? Square it, 9 over 1, 1 squared is 1. And then V, I cube it, 3 cubed is 27, 1 cubed is 1. So if I try to find surface area first, I'm going to start with what ratio? The area ratio. So 9 over 1. Since my number on top relates to my A shape, 1500 goes on top. And I'm going to put x on the bottom. So I have 9x equals 1500. So x equals 1500 divided by 9 is 166.7 meters squared. So now if we go ahead and we try to find volume, nope, this is the volume I'm using. What ratio do I start with? Well, I start with the volume ratio. So I do 27 over 1 equals 3,434.6 over y. So if I cross multiply, y is going to equal 127.2 meters cubed. When you're good with that, go ahead and flip your paper. Notice this one. It says volumes of two similar cones are 8 pi and 27 pi cubed. So I instantly stop and I instantly write SPOV on my paper because I see the word too similar, anything. I put SPOV on there just in case I need it. It says what is the ratio of the lateral area? So I'm looking for ratios, which means I do want to use SPOV. So it says the volumes of my two similar cones are 8 pi and 27 pi. So in SPOV, what does 8 pi and 27 pi relate to? Well, since it's volume, it's relating to volume. So I'm going to erase this, just some more room, and I'm going to put SPOV like this. So since 8 pi and 27 pi relate to volume, I'm just going to do 8 pi over 27 pi. So notice my pi's are on top and bottom, they cross out. So V is 8 over 27. So if V is 8 over 27, it says what is the ratio of lateral areas? So do you think that's S, P, A, or A? Well, lateral area, so I got to find A. So how I find A is I have to go backwards to S first. So I have to cube root 8 and 27. So the cube root of 8, if you don't know that, how you can do that in your calculator is if you hit the math button and then you type number 4, you can hit 4, and then you can type 8 and hit enter, you'll get 2. And then do the same thing with 27. If you hit the math button and then you find the cube root, which is number 4, and then you type in 27, you get 3. So S is 2 over 3, so what's P? 4 over 9. So go ahead, pause this video. I want you to take a stab at number 4. When you finish number 4, unpause the video in my work, and I'll go over it. So I noticed number 4 says 2 cylinders have a scale factor of 2/3. Stop. I instantly write SPOV on my paper. So scale factor is 2/3, P is 2/3, A is 4/9, V 2 cubed is 8, 3 cubed is 27. It says the smaller cylinder, so okay, here's a cylinder. Oops, that's a terrible cylinder. Let's try again. And has a surface area of 78 pi. Find the volume, the surface area of the larger cylinder. So because I'm looking for surface area, I'm going to use the area ratio. So 4 over 9 equals, so small number relates to small shape, big number relates to big shape. So 4 relates to 78 pi, small shape, over x. So now I'm going to cross multiply. I get 4x equals 702 pi. So x equals 175.5 pi meters squared. These next questions are the heavy hitters on these problems. So if I take a look at some of these critical thinking questions, it says if the edge of a cube is doubled, then the volume of a cube is multiplied by blank. So thinking about this might be a little hard for some of you, and so my advice is let's go ahead and let's draw a picture. So if I go and I draw a cube, and I'm actually going to zoom in just so I know I have a lot of space to show my work. So if I draw a cube, and it says the edge of the cube is doubled, so I'm going to pick any side I want. I recommend when you pick numbers, don't pick 1, because 1 sometimes, is special and can be multiplied by itself and gets 1, and any number it's itself. So I would start with the most basic numbers, 2. So since every number on a side of a cube is the same, it's all 2. So let's find the volume. So how you find the volume of a cube? Length times width times height, that's 8. So my volume of that cube is 8. So now I'm going to take my sides, and it says the edges of the cube are doubled. So I'm going to go ahead and double on my sides. So if I double 2, I get 4. So 4, 4, and 4. So what's the volume of those? 4 times 4 times 4 is 64. So the big question is how do I get from 8 to 64? Because it says what happens to the volume. It says the volume of the cube is multiplied by what? So 8 times what gets me 64? Well, that's 8. So being multiplied by 8. So if I were to take any side value for a cube and then double it, its volume will always be changed by multiplying by 8. So now let's look at this next one. It says if the side of a rectangle is tripled, then the area of a rectangle is multiplied by what? So I recommend, let's draw pictures. So zoom in so I have plenty of space. So here's a rectangle. It says the size of a rectangle is tripled. So I'm going to pick any numbers I want for my sides. So I like 2 for this side. So I obviously don't want them to be the same because then that'd be a square. So let's make this one 3. So what's the area of this one? 6. 2 times length times width is 6. So now let's triple my sides. If I triple 2, 2 times 3 is 6. If I triple 3, 3 times 3 is 9. So my area is 9 times 6, which is 54. So the main question is the area of the rectangles is multiplied by what? 6 times what gets me 54? 9. All right? So let's go ahead and let's look at the next one. It says if the volume between two shapes is multiplied by 64, then the areas are multiplied by what? So this, with my areas of my volume, if the volume of my shapes being multiplied by 64, that means my ratio for volume is 64 over 1, right? So I can just go ahead and write SPOV down. So my volume ratio is 64 over 1. So what's my similarity ratio? Well, that's 4 over 1. Then it says the area is being multiplied by what? So what's the area ratio? 16 over 1. So the area is just being multiplied by 16. Let's go ahead and let's do one more. It says a cone of a radius has 3 inches, has a radius of 3 inches and a height of 10 inches. If the radius is doubled but the height remains the same, how does the volume of the new cone compared to the volume of the original cone? So, okay, let's draw a cone. It's my beautiful cone. Hope you all appreciate my awesome cone. It says the radius is 3, height is 10. So it's talking about volume. So I'm going to find the volume of a cone. So the formula to find a volume of a cone is 1/3 pi r squared h. So if I come over here, V equals 1/3 pi. My radius is 3 squared. My height is 10. So I have 1/3 of 3 squared, which is 9. So 1/3 of 9 is 3. And 3 times 10 is 30 pi. When you're making comparisons, it's always easier to leave it in terms of pi, so you're not dealing with decimals. So that's one cone. So now let's find the next cone. It says the next cone, it says the radius is doubled, but the height remains the same. So, okay, so here's my next cone. My radius is doubled, so 3 doubled is 6. My height remains the same, so it's still 10. So now, if I do the volume of this, 1/3 pi, my radius is 6 squared, my height is 10. So 6 squared is 36. 1/3 of 36 is 12. 12 times 10 is 120 pi. That's that volume. So, how does the volume of the old cone compare to the new cone? How do you get from 30 pi to 120 pi? Well, if you can't see it, you just divide big number divided by a little number, and that's what it'll tell you. You'll get 4. It's being multiplied by 4. So volume is being multiplied by 4. So I'm going to go ahead and I'm going to skip number 5 and I'm going to go down here. These are really common problems. I always see these types of problems on standardized tests. People like to use them because they make your brain think, but we have a way to cheat the system. So you have 2 ways you can do it. You can either memorize the rules, or you can make up your own problem. So if it is asking you about 2 different shapes and it wants you to compare them and information about them, just make up your own problem like we were doing above. Let's just make up numbers. This is the easiest method, if you want my opinion. This is the easiest method. So if we look at this example below, these 3 examples are just like the examples above. I just kind of put it more into this is what we should do. So it says the height of a cone is tripled, right? So what happens to the volume? So if I draw a cone, here's my cone. It says the height of a cone is tripled. So I'm talking about two different sized cones, right? So I don't know what my height is. Let's make up a height. Let's pick 3. You could have picked 5. You could have picked 12. You could have picked 144,000. 3 I just picked. But now I'm going to also need a radius. Radius, I would not pick the same number, and I would never pick 1. And remember, 1 is special because sometimes it has characteristics that don't make it easy to tell the difference. So I always pick 2 and 3 when I have to make up my own problem. So volume of a cone is 1/3 pi r, which is 2, squared, height, which is 3. So 2 squared is 4. 4 times 3 is 12. 1/3 of 12 is 4 pi. That's the volume of that one. So now it says the height of a cone is tripled. So my height is tripled, so 3 times 3 is 9. What about my radius? Did it say anything about my radius? Nope, so I keep it the same number I picked as 2. So now find the volume of that one. 1/3 pi, my radius is 2 squared, my height is 9. 2 squared is 4, 4 times 9 is 36. 1/3 of 36 is 12 pi. So how do I get from 4 pi to 12 pi? Well, I multiply by 3, which means the volume multiplies by 3. So I want you to go ahead and I want you to try these bottom 2 problems on your own, and then if you need help you can unpause it and I'm going to go over it, or if you just need an extra eye to see it again, I'm just going to go over it, but it's up to you on how you want to finish these last 2 problems. So it says the height of a cylinder is doubled, what happens to its volume? So I have a cylinder, if I can draw, here's one cylinder, here's another cylinder. It says the height is doubled, so I'm going to start with 2, and then I'm going to double it in 4. So I'm talking about the volume, so if I want the volume of this guy, the little guy, volume formula, if I look on my formula sheet, is pi r squared h. So pi, my radius, I didn't pick one, so let's pick 3. 3 squared, my height is 2. So 3 squared is 9, 9 times 2 is 18 pi. If I come over here and I do this one, v equals pi, my radius stays the same, so it's 3. 3 squared times 4. 3 squared is 9, 9 times 4 is 36 pi. So how do I get from 18 pi to 36 pi? Well, 36 divided by 18, I multiply by 2. So volume multiplies by 2. And if I do the last one, it says the radius of a sphere is doubled. So here's a sphere. The radius, let's start with 2. It gets doubled. So the radius gets doubled as 4. What happens to its surface area? So surface area is 4 pi r squared. 4 pi, radius is 2 squared. 2 squared is 4. 4 times 4 is 16 pi. That's surface area over here. Surface area on the bigger one, 4 pi, my radius is 4 squared. 4 squared is 16. 16 times 4 is 64 pi. So how do I get from 16 to 64? If I don't know, I just would do the big number divided by the little number. So 64 divided by 16, multiplied by 4. So surface area is being multiplied by 4. So again, I always pick the little numbers. I usually always pick 2 and 3. If it doesn't give you numbers, you just make them up. You pick the numbers you want to use. I always pick 2 and 3. And if it's problems relating to circles, so circular shapes, I always leave it in terms of pi. That way I'm not dealing with decimals. If you have questions, come and see me.